In this series, for the next few videos, we are going to build a task manager, kind of a to-do management app. Now, it sounds a little too basic, and there are already a lot of tutorials covering this kind of projects like basic CRUD API, etc. But we are going to do this project a little differently because in the last video, we built a production grade Go boilerplate. I have pushed the GitHub repository here, and this boilerplate has a Go backend and a React frontend. And in the backend, we are trying to cover as many production use cases as possible. Things like logging, monitoring, observability, transactional emails, and background jobs using Redis, and authentication middlewares, advanced database query patterns, config management, clean error handling, and a lot of other patterns. On top of that, we have built this code base as a monorepo, and we have first class tooling support for TypeScript based tools like TS REST for our OpenAPI generation. By the time we finish this project, we'll have this very clean OpenAPI interface where we can test our APIs and a lot of other features that a typical production grade backend has. And that's why I think this project is very different from all the other existing projects in YouTube, which shows you how to create a to-do management app, a basic CRUD app, but we'll try to cover all the other stuff surrounding a basic CRUD app, which makes a project which you can call production grade. And next, we built this boilerplate in the last video, but we did not really see how all the different modules, all the different features come together, how they actually work, why we did certain things the way we did it. And because of that, I thought of starting with a project which does not go too heavy on the business side, on the business logic, so that we can build something, we build something useful, we build something robust enough, but the business logic is light enough and relatable enough that we understand our project structure better. We understand our boilerplate better, how everything comes together, so that from the next video, we can pick up some advanced SaaS backend or any complicated project once we have internalized all the different modules of this boilerplate. So what does this project have? This is the landing page, a typical landing page of a to-do management app. And we have authentication using Clerk. We can sign in with Google. After sign in, we'll land in the dashboard. And here we can see all our statistics, how many tasks we have created, how many tasks are active, how many are overdue, how many are completed. We can see all our created categories and all our created tasks here. If we go to view all, we'll land here, which is the to-dos page, and we can edit a particular created task. We can edit the name, description, we can change the status, change the priority and the category. We can also add files. For example, let's say we can upload the file, and then once the file is uploaded, we can click on it and view the file, right? So that's about to-dos. We also have categories. We can create categories. We can see all the created categories. We can create a new category which will have a name, description, and color. Also support for custom colors. Then we can also create a new task which will have the title, description. You can choose the priority, category, what is the due date of the task, and we can add additional files. The files will be uploaded to S3, or at least an S3 compatible object storage. We'll be using Savala object storage for this project, which is an S3 compatible object storage. And behind the scenes, it uses Cloudflare R2. Then we also have settings page, which provides some features to manage your user account. And we will not be building the front end of this project in this series. We will just be focusing on the backend side. I'll go through all the modules step by step in the backend side, but by the time I finish this project, I'll also add the front end code in the repository, since it is a monorepo, and you can test it out in your own local. You can change things and you can enhance it or modify whatever you want. On top of all the features that we saw just now, we also have cron processes to send users emails about all their overdue tasks, and also send them emails about their weekly reports, how many tasks are completed, how many tasks are overdue, etc. Right? So we also have transactional emails and cron based email setups. A lot of interesting things to learn and a lot of interesting features to build. So let's get started with this project. And the reason I built this whole boilerplate, I went through the different modules, how we connected all the modules together. If you can watch the video in the description about building a production grade boilerplate. The reason I built it was because from the next time on, like for this project, we can just clone the boilerplate and we can get started by building our backend instead of focusing hours on setting the project boilerplate like logging, configs, and observability and our database connections, etc. etc. There are a lot of components in a typical backend that we do repeatedly. That's why I have put together this boilerplate so that I can clone it and get started with all my future projects. And even you can do the same when you are starting, either you are following along or you're watching the video and you want to build it on your own at a later point of time. That's what I will do right now. I'll copy the cloning command and I'll clone it in my local and I'll get started with implementing all the features for our to-do management app. Now going back, let me open the terminal and let's clone it here. Then we'll write the project name. So for this, I'm calling this project Tasker for managing our tasks. And after the cloning is complete, let's cd into our project is Tasker and open cursor or VS Code, whatever you're using. Let me zoom in a little bit. I hope it's visible. This is the boilerplate. In the last video, I have completely explored how we built this backend boilerplate from end to end, and also the packages, the emails package, the OpenAPI package, and the Zod package. Right. Later on, after the video, I also pushed a front-end boilerplate which integrates nicely with our backend boilerplate. For example, we have this client which is called API client, which takes our contract, the OpenAPI contract, and it consumes it so that we have a type-safe client in our front end, so that we don't have to manually manage all the URLs, all the body params, the path params, query params, whatever. We'll see how this works in the end of the project, but we'll not be building the front end part here. Okay. And this is our backend boilerplate. The first thing I want to do is let me run one install so that we install all our TypeScript packages that are in the packages folder and in the front end folder, so that while developing, we don't get any type errors and such. An install that will create a node modules here. And after that, let me also run one dev so that it builds a couple of things and we don't get type errors while we are developing. After that, we have to rename stuff since we have named the project boilerplate here. So everywhere, if we search for the string boilerplate, we'll see it everywhere because that's the name of our boilerplate project. And what we want to do, we want to change the name boilerplate to Tasker, because that's the current name of our project. So let me just do a universal replace. We'll select all the strings with the name boilerplate and replace them with the name Tasker, and hoping it does not break anything, right? So let me just clear up this README file since that was applicable for the boilerplate, and we'll keep this blank and we can refill it later on. Once we have replaced the small case boilerplate, let's just also look for the uppercase boilerplate in case there are any. And it did find a couple of instances where we are using the uppercase boilerplate. So let's just replace that with uppercase Tasker. Great. Now how about this? I think this Tasker, replace that also. Okay. I think with that, we have all the instances of boilerplate replaced with Tasker. We have an error here. It's Tasker, OpenAPI contacts. Let's check the package.json of this. This is correctly resolved. I think the replacing messed up this part, the package.json. So this should be /Zod here. Let's also check the Zod package if the package.json is fine there, and the package.json of our front end. This looks fine, and let's run one install once so that it can resolve all the renamed folders and files. Tasker Zod not found. The name is fine. Go to This is for the Zod. This looks fine. And inside OpenAPI, this also looks fine. So let's just go ahead and run a cleanup once so that we don't have any residue of the previous package names. For that, we run one clean that will clean up all the node modules and tsconfig caches, and from the root also we can delete the burn.log file. Okay, after this, let's run one install again. And after that, if we run our development server, everything should be running fine. And we have renamed our project to Tasker. Okay, and if we go inside backend and go inside apps/backend and try to run our server, I think we have to rename. We got this error because we have not renamed our folder, which is still Go boilerplate. Let's rename it to Tasker. Okay, let's try to run the command again. And we got this huge error, which are basically all our validation errors for our config. So if we go inside this file config.go, and here we are declaring some structs for our different use cases of different features. And we are validating them using required tags using our Go validator library. So we have to create a .env file and provide all these different configs so that we can successfully run our server. And for a couple of them, we have to sign up for some services. For example, for getting our secret key, we have to sign up for Clerk. For getting resend API key, we have to sign up in resend. For Redis, we will be running a local Redis instance for now when we are building our project. But when we deploy our project, we'll be using Sevala's Redis database. Same for the database config. We'll be using a local Postgres server while we are developing, but while deploying, we'll be using Sevala's database provider. For server config, these are mostly static configs like ports and timeout values. Then we have our observability config, which will require us to sign up to a New Relic account and create a new application there. So those are pretty much all the accounts that we need to create first so that we can populate our .env and we can successfully start our demo server. Then we'll start building our actual project. We can start with Clerk, and after signing in, you can go ahead with your Google account or GitHub account. Here I have already created an app which is called Alfred, but let's create a new application and we can name it as Task. We'll enable email and Google for now for different authentication methods that we are allowing our users to use. Then this is the preview of how the authentication screen is going to look like. Let's create the application. After you create the application, we'll get your keys, this Clerk publishable key and the Clerk secret key. The publishable key will go in your front end where you're going to allow users to authenticate into your application, and the secret key is going to go in the backend. Now let's create our .env files in both front end and backend so that we can paste our keys. In front end, we'll create a file called .env.local. Sorry. Should be low, and the content will be there will be 3 entries. The first one will be our public key, so let's just copy this part and paste it here. Then our API URL, basically the URL where our backend is running, and our environment, which is local. In production, it will be something like prod, or in staging, it will be like dev, etc. Same way, let's copy backend key also, and we'll need to create a .env file. So let's copy our .env.sample and create a new file called .env and paste the sample here first. Now this is our secret key for backend. I'll be deleting all these applications and keys after this video. I'm fine with exposing it. Now this will go inside our secret key for authentication, and we are prefixing all the variables with our app's name so that they don't clash in a server environment if we are hosting in our custom EC2 instance or something like that, right? And that is all with Clerk. After that, we'll come back later on to test our auth flow, but for now, that's all we need for our Clerk integration. Next, we'll need our New Relic license key for our logging, monitoring, and observability setup. So I'll just sign up with Google and create an account using my Google account. Oh, I accidentally went with sign in. It should be sign up. Select our Google account and you can choose your region. Let's go with United States. After signing up, you will land in your dashboard, and the thing that we need is a license key. So let's select go, and here we will have to create a new key. And after this, you have to copy this key since it will be only available one time. So let's copy this and let's go to our app, observability, and our license key. Let's paste it here. Okay. Now going back, we don't need a user key now, right? So we can close this now. Let's just cross verify if we have the key here. So this is the key that we created for ingesting data into our New Relic instance. And that's all we need. We can come back to this later. And when we click on APM and services, we'll find the name of our service here, which is Tasker. Once we start ingesting data into our application, we'll test that part at the end of our project. But for now, that's all we need. Now let's go to resend. We need resend for sending emails to our users. Go to sign in and let's log in with Google account. Continue. After signing in into resend, you'll land in your dashboard. And since I had already used this account, I have some reports available, but for you it will be blank. And you can go to here at the API key section. I have this key already created, so you can just go ahead and create a new key. Let's name it Tasker. Permission, let's give full permission and click on add, and let's copy this. Going back, where is the recent key? All right, let's paste it here now. All right, that's all we need for our recent integration. Then we'll need access to an object storage. So we'll be using Sevala's object storage for our document upload for our task attachments. Now, after you sign up with your account in Sevala, you'll land here in the dashboard and you can go to object storage. I already had an object storage created, but you can create a new storage. Let's name it Tasker. Location, I'm selecting Asia Pacific because I'm from India. But depending on your location, you can select whatever suits you best. Let's create and let's go inside Tasker. And after this, you can go to settings. And these are all the information that we need to connect to our instance, our object storage instance, so that we can upload files, download files, etc. So we'll need the bucket name. Okay, the keys are missing here. So let's just paste the keys first. These are the keys that we need for accessing our object storage, our Sevala object storage. Now Sevala behind the scenes, it uses Cloudflare R2 for its object storage needs, and Cloudflare R2 is a S3 compatible object storage, which means that you can use the SDK provided by AWS and you can connect to your Cloudflare R2 instance and you can perform whatever upload, download tasks that you want to perform, which means that Cloudflare does not have to create its own SDK since it is completely compatible with AWS SDK. And since Sevala uses Cloudflare R2 behind the scenes, its object storage instance is also compatible with AWS S3's SDK. That's why we are using AWS SDK to interact with our Sevala object storage, and we are also naming it AWS. In case in the future you want to migrate to S3 or something, it won't be a big hurdle. So these are the keys that we'll need: the region, which will be APAC, and the bucket, which we just, and the bucket name, just copy here and paste. The endpoint URL, just copy that, paste the access key and the secret key. This is the access key and this is the secret key. And that's all the information that we need to connect to our object storage using AWS SDK to Sevala's object storage. And that's pretty much all the accounts that we need to integrate with. So I think that pretty much wraps up all our needs. So let's just see what are the environments that we are using. The env field is local, that is fine. We're running our server in 8080. These are good default timeout values. Allowed origin basically means where is our front-end URL, so that we can allow cross-origin requests from there. And these are database configs. Now, if you are running Postgres instance, either in your native machine or through Docker, and you are exposing in 5432. I'll not covering the Postgres installation and starting because it has different installation methods depending on what operating system that you're using, either Windows, Linux, Mac. So you can figure that out. You can just do a Google search how to install Postgres in your respective operating system. Now this is what your typical config will look like if you want to connect to your local Postgres instance. But since my Postgres instance runs in a different home server, which is not the same machine that I am currently working in, and it is a home server and I'm connected to it through Tailscale, right? So I have to provide a different host name. This is the host name of my machine. It's running inside a Docker container inside Proxmox. So you don't need to worry about that. For you, it will be localhost, but for me, it will be this host name because the Postgres instance is running in a different host. And the rest of the fields we can keep as default. Secret key, we already pasted. Recent secret key, that's already done. Then comes the Redis part. Again, you can run Redis in your local or your Docker instance. And once that is running, you can connect to that using this URL. This is the default port of Redis and this is the default URL, assuming you are running in your local. And since my Redis instance is again running in a Proxmox home server, for me, the hostname will be a little different. This part, this is my hostname and this is the port. Next, we have already configured this Sevala's object storage configs. For observability configuration, the name of our service will be the name of our app, which is the name Tasker. The environment is development. The default logging level will be debug. And we want to print whatever login information in our console instead of a file or sending to a different server, right? Since it is our local environment. Slow query threshold. I don't think that we are using this. So let me remove this. Then comes our New Relic config. This is our license. We are enabling log forwarding. We are also enabling distributed tracing, and debug logging is false because if you enable debug logging for New Relic, it prints a lot of information that we don't really need until we are trying to debug something from the New Relic side. And these are some health check configs. Health check is enabled. Interval every 30 seconds, we want to check our health. And this is the timeout, and we want to check the health of database. Right? That's all our environment variables that we need to start our server. Now, if we try to run the same command, which is task space run. All right. It is giving an error that it is not able to ping to this particular database, the database named Tasker. For that, we actually have to create a database named Tasker. And I am using this database management software, which is called Table Plus. It has a very neat user interface and it works in pretty much all the operating systems, Windows, Linux, or Mac. You can explore that, but you can of course go with other solutions like pgadmin or whatever that you're used to. Right? Let me connect to my host, which is the Proxmox instance. And here I'll create a new database. These are the existing databases. I'll create a new one and I'll name it as Tasker. Let's connect to that. Since we have not created any tables or any functions or any kind of migrations, this will be currently empty. But we'll come back to it after we have created some data, we have created some tables, and we can see what are the populated data here. Now going back, if we try to run our server, you can see that connected to database, our background job server has started. We are using async. If you have referred to the boilerplates video, we are using the library async to run our background job processing server. And this is coming from async. And finally, our log that our server has started in the port 8080. Now, if we try to go to our API docs, this is our open API testing platform. We are using a service called Scalar, and it provides a very nice user interface for testing our APIs as compared to Swagger UI. It is a more famous option, but Scalar provides a modern UI using an open API document that we have generated. So our server is running, and if we try to run our health check, let's try to test this endpoint, and if we try to send this, we get this response back. The environment is local, status is healthy. This is the current timestamp of the server. This is our database health. Response time is 6 milliseconds. Database is healthy. Same for our Redis. The response time is 4 milliseconds, and Redis instance is also healthy. So our server is running, our database is running, and our Redis instance is running fine. And our server is successfully able to connect to our database and Redis instance. With that amount of setup, I think we are ready to get started with our backend implementation. Now, as I've mentioned, we are building this to-do management application, and I have already shown what are the different features that we'll have in this. So the first thing that while building your backend application, the first thing that you think about is what are the different features, what are the different modules that you're providing. So from our demo, we have seen that we have a couple of to-dos, and the to-dos will have a couple of fields like priority, name, description, and the due date. Similarly, we have categories. We can create categories, fetch all categories, and we can link to-dos with categories. And similarly, we'll have attachments. We'll come to the attachments later on once we have a basic to-do system ready. So that's all the basic features that we need for this backend system. The first thing that we'll do is design our database schema. Since it all starts with the structure of your data, we'll write our first migration, our database migration, so that we can apply that migration and create what are all the needed tables for our to-do management app. So if we go to our database and migrations, this is an initial setup of how your migrations files are going to be stored. As I've already mentioned in the boilerplate video that we will not be writing down migrations, we'll only be writing up migrations. So let's just clear this whole thing up. And for the first migration file, I want to create two functions that we are going to use repeatedly. I'll just paste it here and I'll explain why we are creating it and why do we actually need it. This is one function called camel, and we have another function called trigger set updated it. Now the first function camel, you don't have to understand this syntax. Even I did not write it myself. I took it from Stack Overflow or some Claude or something. But this function, the whole purpose of this function is it will take a particular row from a table and it will convert all the fields of that row to camel case. So usually the style we follow while we are creating our database schema is lower snake case. So if we have a field called first name, this is how we will be storing it in our database. This is the name of the field. But when we actually send data to our front end, to our client, the usual convention of JSON structure is we want to follow camel case because that is the standard structure we have in our JavaScript ecosystems. When we are sending it to front end or any client, we convert it to camel case. So it is going to look like this first name, right? And that is the whole reason we are creating this function called camel. When we are fetching rows, we will pass our particular row or a couple of rows into this function, and it will take in this format all the fields and it will return in this format all the camel case, right? That is the use of the first function. Then we have a second function called trigger set updated it. Now this function is basically for creating a trigger for a particular table. Let's say we created our table called to-dos. Now for that table, what we want to do, we have a field called updated at, and every time we update a particular row, either the name of the to-do, the description of the to-do, we want to update the timestamp of the field updated at for that particular row to the current timestamp. And we can of course do that in our code. Whenever we do some kind of update, we also update the updated at field manually. But if we create this particular trigger, in case we forget to do in our code, it will be automatically managed by our Postgres database. That's the content of the first migration that I want to keep. Then let's go ahead and create a new migration. cd apps and backend again, and this is the command for creating new migration. By the way, for this to work, you will have to install this CLI tool called Task. You can look that up, and also the CLI tool called Turn. If we go to the task file, we are using this particular tool called Turn, which is a CLI tool, and it is created by the same creator who has created the database driver called PGX that we are using in our project. And this tool is used to manage migrations for a Postgres database. It is limited to Postgres. Since we are using Postgres, we can use this particular tool. To create a new database migration file, we can write task migrations new, and the name will be, let's say, to-do. And that in turn will create a new migration file, which is called to-do.sql. Let's clear that up. And in this migration file, we'll finally write all the database tables all the indices, and everything that we need for our whole to-do management system. The first thing that we need is a to-dos table, but before that, we also need a to-do categories table. And since our to-dos table will have a field called category ID, which will store the category of the to-do, first we'll need to create the to-do categories table, which will be unique to each user. So each user will have their own set of categories for their to-dos, right? So this is what our to-do categories table is going to look like. Let me just disable my cursor suggestions. Disable, right? Now we are creating a new table called create table to-do categories. Now this is the style we are going to follow. Every time we create a table, it will be plural. And if it is multiple words, we'll separate them using an underscore. And these three fields are default fields which will be present in every table. That's why we are keeping them separately. The ID, it will be a UUID, and UUID, this is what a UUID looks like. If I just paste it here, this is what a sample UUID looks like. And each row of our to-do categories will have an ID in the format of a UUID, which looks something like this, which is unique universally, right? So we are creating the first field with ID, which is a UUID, and this is also the primary key for this table. And if we don't provide our own ID when we are creating a new row, then we are asking our database server to create a new UUID and assign the row that particular ID. That's what this function does. By default, if no ID is provided, default generate a UUID and assign it to that row. Same way, we are creating two fields, one created at and second is updated at. Now created at will be pretty much fixed. The first time that we create a new entry in our table, a new row, for that row, the created at will be taken as the current timestamp when the row was created, and that will be its value. So instead of writing like this, what we can do, we can select and we can write time EZ, which basically means timestamp with time zone, which we need if you want to appropriately format our times and dates as per different users from different regions. Now the second field, updated at. Now this field will be updated every time we update a particular field, for example name or color of a particular category. Now these are the default fields or default columns of our to-do categories table. Then comes the columns that we need, is user ID, which is going to be a user ID clerk, and the data type we are providing is text, and it is not nullable. We have to provide a user ID for each row. Then the name of the category, again, that is also not null. The color, by default, we are providing this gray kind of color for a category. Then description, which is optional, which means it is nullable. We can provide a description or we can completely skip it. Now let's just create two indices so that any kind of operations that we perform on these categories are more efficient. Indices help us query better, and when we are performing different joins, inner joins, left joins, indices help improve the performance. The first index that we are creating is on user ID. We are just naming it something, and it is created on the field user ID, so that every time we join the to-do categories table using the field user ID, or we fetch our to-do categories using the field user ID, it is a little faster. That's what we are creating this index for. Similarly, we are creating a unique index so that a user can create only one category using a particular name, right? All the names of the categories have to be unique. That's why we are creating a unique index on to-do categories table using user ID and name. After that, as I have already mentioned, we created this function called trigger set updated at, and using which we can set a trigger on our updated at field, so that every time we update a particular row, the updated field is automatically set to the current timestamp. For that, we can use this particular statement, which says this is the name of the trigger, and it performs an operation which updates the updated column to the current timestamp using the function that we wrote in the first migration. Now that we have our to-do categories table created, we can move on to our to-dos table. This table is also going to follow a similar structure. We have our default fields here, an ID, created at, and updated at. Let me update this to the same thing. This will be time is yet. After our default fields, we have a couple of fields here. First is the user ID, the ID of the user, the clerk user ID of the user who created this to do. Then the title, which is of data type text, description, which is nullable, title and user ID mandatory fields. That's why we have written not null here. Same way, status will have different status. For example, draft, active, archived, etc. That will maintain in our own code. But for now, we have given the data type as text. Same way, priority will have medium, low, high. The default priority will be medium. We have two timestamp types for due date. When is this task due and the completed date. Every time we check the field completed date, for example, we have a to do and we want to check the mark so that that to do is marked as completed, and we'll record when exactly we marked a particular task or a to do as completed. Same way, we have created this field called parent to do ID in case one to do can have multiple sub to dos. If you want to build a feature like that in the future, we have added this another field called parent to do ID, which is basically a foreign key of itself. Then we also have a field called category ID, which references to do categories. The table that we created first is a foreign key referring to the to do categories table. Then we have a field called metadata, and the data type is JSON-B. Now, JSON-B is a binary JSON data type, which is provided exclusively by Postgres, which is a more efficient format of JSON when we are serializing and deserializing it. Then we have sort order. If we want to sort the to-dos in a particular order using drag and drop, then using this particular field, we can implement that feature. And after this, we'll also need a couple of indices for our to-dos table. And these are user ID. If you want to fetch our to-dos using user ID, that's why we have created an index on user ID, then using category ID or parent to-do ID, or using a particular status or a particular priority or a particular due date, etc., etc. Right now, I have created all these indices since it's not clear that what is the query type that we are going to use heavily. But once you are clear on your business requirements that using this particular field, users are most likely to query their to-dos, then you can optimize accordingly. You can drop a couple of indices and prioritize the indices that are used more frequently. Then in the end, we'll also create a trigger for this so that every time a particular row of a to-do is updated, we also update the updated at field using the current timestamp. Similarly, we also need another table for our to-do comments. If we want to add comments to a particular to-do over the time, that's why we are implementing this feature. And this is what it is going to look like. We have a field, we have this create table statements, and we call this table to do comments. These are the default fields, ID created at, updated at. Then it references to do using this foreign key called to do ID. And if a particular to do is deleted, then all the comments related to that to do will also be deleted. And that happens using this particular statement, which says that this field refers to a particular row in the to-dos table. And if that row is deleted, also delete all the rows related to to-do ID in this particular table. Then we also have user ID, which user created this comment, and also the content of the comment, whatever text that we place inside the comment. And we create two indices, one using to-do ID and another using user ID, and a trigger for our updating needs. And that's pretty much all our tables that we need for our initial version of to-do management system. In the end, we also want to add a couple of constraints, which is on the table to-dos, we want to add a constraint with the name no self parent, which checks that a particular to-do cannot be its own parent. So every time we create an entry in the to-dos table or update a particular entry, it will check, this constraint will run and it will check that the parent to-do ID field and the ID field can never be the same, so that a to-do cannot be its own parent. That is one safety check that we are adding. Another for hierarchical queries, when we have parent to-dos and sub to-dos, we are creating an index so that we can retrieve all the to-dos of a particular parent using the sort order field. Similarly, another composite index that we are creating for these three fields, which is user ID, status, and priority. Again, these are the indices that you have to optimize after you are aware of your user interactions. So since we have already integrated our metrics integration, which is the New Relic integration. Using that, you can learn more about your user behaviors, your database query times, and all these things, and accordingly optimize your queries with different indices. You can drop these existing indices if you find out that these are not really useful for your use case, and you can create new indices depending on your user behavior. With that, all the migrations that we need are complete. And to apply this, we need two things. Let's clear this. Make sure you are inside your backend folder, and there we need to run task migrations up, and we have a confirmation screen here. And when you run it, you'll get an error that a connection string is needed. So if you go to your task file and the migrations up command, it needs a environment variable which is called tasker dbdsn, which we have declared here. So we need to expose an environment variable named tasker dbdsn, which will contain our whole database URL, using which our tool, which is the turn CLI tool, it can apply all the migrations on our database. For that, we can run this export. Now, this is a command for Mac. For your operating system, you need to figure out what works. This is what it is going to look like. The name of the database will be Tasker, and for you the host name will be different, which will be something like localhost, but here I have provided my host, which is the Proxmox host. Then the name we want to keep is Alfred Tasker, and this looks good. Let's enter. We have exposed our environment variable. Now let's go ahead and run this previous command again. And if you see this screen, which is just printing all your migration statements, and there are no errors here, then that means that your migrations have been applied successfully. So if you go back to our table plus and we refresh, we can see that we have created two functions, camel and trigger set updated at, and we have all these tables called schema version, to do categories, to do comments, and to do's. Schema version is the table using which our tool, the turn migration tool, it keeps track of what is the current migration schema that is applied. Since in our migration file, if you go see the current schema, the latest migration schema is the number 2. That's why we have the number 2 here. Now, every time we apply a new migration, it will check what is the current migration schema number and what is the latest one. If the current one is the lower one, then it will try to apply that. That's how the whole migration thing works. Similarly, we have other tables. There are 3 tables: to do's, to do comments, and to do categories. And these are all the fields. Since we don't have any data, it's empty now, but we'll come back when we are testing our modules. And with that, we have set up our database needs for our to-do management system. The next thing is, after you have created your database schema, the next logical module that makes more sense to tackle is creating your models. The models are your data structures, are Go structs, which will have a one-to-one mapping with our database tables. So each field in our database table will have a corresponding field in our Go struct, our model, which we call model. For that, let's go to our models folder. We already have a base file which has all the default fields, so that we don't have to write ID created at and updated at every time in every model. That's why we have created a base model, and which will have ID created and updated at, which we can embed inside other models. So the first model that we need is to-dos. So let's create a folder called to-do, and inside that we create a file called to-do, and the package name will automatically taken as to-do. Then we'll create a struct called to-do, which will have the mapping from our database to our Go data structures. But before we create our to-do struct, we'll need to create 2 enum types. Since if you see here in our database migration, in our to-dos table, we created these fields. One is status, one is priority. Status can have a couple of fields allowed inside it, and same for priority, it will have low, medium, or high. So for that, we have to create an enum type. The enum type is basically a data structure which can only hold a predefined set of values that you create beforehand, so that it is type safe. We cannot assign any random string to it. It can only be limited to a couple of values. So the first enum that we need is status, and it will be of type string. Now this is a custom type that we have created, and this is how you create enums with const. And For each enum entry, we write the name of the enum, which is status draft, and the type of that enum will be status, which we just created right above it. And then comes the string value for that, which is draft. Similarly, we can go ahead and create the other three, which is status active, status completed, and status archived. And following the same pattern, we can also create our priority enum for the values low, medium, and high. Then we have the to-do struct finally. As I have mentioned, this struct is a direct one-to-one mapping of the table that we declared here, right? And the way we map it is all the fields that are mandatory in our database, in our table, will be of value type. For example, the user ID and title and status, priority. These are all the fields. If we notice in our migration, user ID is not null, title is not null, status is not null, priority is not null. All the fields that have the constraint of not null will be of value type in our structs. And all the fields that can be nullable, which can have null values, will have pointer types. And the reason for that is the zero value of a string type is an empty string, and the zero value of a number type is zero, and etc. And the zero value of a slice or the zero value of a pointer, these are the reference types. For these, the zero value is always nil. And because of that property, we can differentiate between whether a particular value exists or a particular value exists, but it has zero value. For example, in description, if we have an empty string, because we have the type of description as a pointer to a string, we can differentiate between if the description is actually absent or the user has manually provided the description as an empty string. So that is the reason. This is the pattern you'll notice everywhere. Different developers implement this in different ways. Some people like to use omit empty tag in JSON in structs, but I don't like to do that because a nullable field makes more sense to me than an absent field. Now coming back to it, that is the first pattern that we notice here. All the mandatory types will have value type and all the optional types will have pointer type. Apart from that, in our database, if the data type is text, then we'll map it as string. If it is of something like enum type, then that's what we did here for status and priority. We created our own custom type, and that type can have 3 different types of values, and we provided that here. Again, this is a value type because it cannot be null. If it is any kind of timestamp, then we provide time.time. Now time comes from the time package provided by the standard library. Same for UUID. For all the fields that are of type UUIDs, we use this package. This should be Google. We use this package which is from Google, and using that we can provide the type as UUID. Again, these are also pointers because parent to-do ID, category ID can be null for a particular to-do. These are not mandatory fields. We are getting an error for metadata here because we have not defined the type for metadata yet. So metadata can be something like this. Even though in our database we have provided the type as JSON-B, which can be any kind of JSON, but in our code we want to maintain a particular strict data type for metadata. So this can be the metadata. We can keep a couple of tags. Now, ideally, we should create a different table for tags, but here we have just created a single field called tags, which can be an array of tags for a particular to-do. Similarly, some kind of reminder, then the color of the to-do and the difficulty, etc. Random data that we want to associate for a particular to-do. Now this error is gone. We have the particular data type for metadata. Now coming back to the second important part are the struct tags. Now, as I've said, in Go, we can use struct tags to provide different metadata for a particular field. So in this case, for all our models, we use 2 different kinds of struct tags. The first one is of JSON, and the difference is in Go, we have to write the field names, variable names in a particular format because of the community style guide. For example, for a field called user ID, in JavaScript, we write something like this, user camel case, but in Go, we write it as upper camel case, but with one change that all the abbreviations, we do not make it small case after the first letter. So if we have something like ID, all the letters will be in caps, right? So the first tag, which is of JSON tag, we are providing it because when we are sending data back to our front end, all the structs which look like this with the first letter uppercase and the abbreviations all caps, they will be converted into this format, the lower camel case format, so that it aligns better with the JavaScript ecosystem and the JSON practices. Similarly, the second struct tag that we see everywhere, which is of DB. Now this is for our database driver, because when we are trying to read data, when we are trying to select data from our database, we will run our query, but after the query results some rows, those rows will have to be deserialized into some Go structs. And in those structs, how will the database driver know that which particular field from database will go in which field in our struct? So using this tag, which is DB tag, our database driver can derive that if a row has a field which is of this format, user underscore ID, then that field should be loaded inside this field inside the struct, which is user ID, but in a different format. And that is the use case of all these DB tags. The first one is for JSON serialization and deserialization, either from reading data from front end or sending data to front end. And the second one is for database. Whenever we are trying to deserialize the data that we retrieved from our database to our Go structs, we'll use these DB tags to perform the deserialization without causing any mismatches or errors. And that's pretty much all there is to explain in this part. We covered all the one-to-one mappings from our database table and the difference between using a value type and a pointer type, and why are we using the struct tags, right? That covers our to-do model. Now let's create a categories model. We create a new folder which will be called category. Inside that, again, we'll create a file named category. The package will be automatically category, and inside that, again, we'll have to map whatever database table that we have, all the fields, to our Go struct. Since I've already explained this part, there is nothing much to discuss here. This is what it will look like, the category struct. We have embedded our model.base, which is coming from this base.go file, so that that particular struct will have all these three fields: ID, created at, and updated at, with just a single line, right? That's why we are embedding this particular struct inside this. After this, in category, we had 4 fields in our database table, which is user ID, name, color, description. Since description can be null, that's why we are using pointer here. Again, we are using JSON tags with the camel case and DB tags with this style, is a lower snake case format. And that takes care of our category model. And the last one is our comment model. Let's create a new folder, comment, then inside comment we'll create a file comment, and similarly the same patterns will repeat. This is what a comment.go file will look like, and this is what the model will look like. Let's replace this with Google. This is the wrong import, and with that we have fixed it. Again, we have embedded our model.base, which will take care of the default fields. Then we have to-do ID, user ID, and content. None of them are nullable fields. That's why we have used value instead of pointers. With that, all our models are taken care of. After models, the next thing in the hierarchy. So we are going from bottom to top. In the root level, we have our database, since that is the final source where all our data is going to and coming from. After that, we have our models, because using models will be able to deserialize whatever data that we fetch from our database into our Go data structures. And after models, the next thing that comes in the hierarchy is repositories. Repositories are the point of contact between database and our business logic. And we create different repository methods so that we can run different types of queries, but we'll keep it as unit level. The service methods can call different repository methods depending on our data needs, but we will try to keep our repository layer as unit layer as possible. So it should be doing one thing and only one thing. But before we start with our repository layer, the next thing that we should tackle is our DTO layer. Now, DTO is also known as data transfer object. DTO we call basically everything that comes inside our app through either through body or path parameters or query parameters, and whatever that goes out of our app, whatever we send in response. And before we start with any feature or with any module, we should ideally think about what are the endpoints that we are going to expose and what are those endpoints are going to send. So we should know exactly the kind of data that we are expecting from our client and the kind of data that we want to send to our client before we actually implement that logic of sending or receiving data. We should clearly define our data types, which gives you a very accurate mental model so that you can design your repository, service, and handler layer accordingly. Let's go ahead and finish all our DTOs, all our input and output data types for all the endpoints. Then we can jump into our repository layer, implement, write our database queries, and finish our business logic. Now let's get started with to-do DTOs. All the API endpoints that we are going to expose in our to-do model. So let's create a file inside our to-do folder where we are going to keep our DTOs. Call it dto.go. The package will again be to-do, and here we'll write all our input structs, whatever that we are expecting for each endpoint. Now the first one is obviously going to be our create to-do endpoint naturally. So let me just add this comment here so that we can separate different DTOs appropriately. And this is what our payload is going to look like, which is called create to do payload. Now let's go through it to understand what exactly are we doing it, so that from the next time on, all the DTOs we can create quickly. Again, the same logic applies here. This is exactly the structure that we are expecting from our front end, from our client. And since this is a create endpoint, method is going to be post, and in post, naturally we send our data in our request body. So we are expecting all these fields in our request body. And since this is a Go struct and we have used JSON tags here, when we read whatever request body that is coming from our client and deserialize into our Go struct, the client will send us fields which look like this, right? Which are lower camel case. But when we access those fields, we'll be accessing through our struct fields. So these JSON tags are important and they have to match the format the client is sending us data in. Next is the value versus pointer thing. Again, we have the same logic here. All the fields which can be null, which are optional for us, it does not matter the client sends us or not, those will keep as pointer so that we can differentiate between whether the client sent us a nil value, a null value, or they sent us a zero value, but they still sent us some data. For example, in the description field, if the client sends us an empty string and we use a value type here, there is no way for us to know that whether the client intended the description to go empty or they just did not send anything. And since Go follows this zero value principle, the description field remained as empty string. And because of those reasons, we are keeping it as pointer because it will be easier for us to understand the intention of our client. Similarly, for all the other fields, priority, due date, parent to do ID, category ID, and metadata, all these fields are not mandatory. The only thing that is mandatory for creating a to-do is the title of that to-do. And that takes care of this part. And the JSON tag I have already explained. Then comes the validation. Since we are using this package called Go validator, which comes from this, we can pass our validation rules using a tag which comes under validate, and we can write our rules here. So for the title, we are saying minimum it should be 1 character, maximum it should be 255 characters. Same for description, but before that we are adding one value here which is called omit empty, which basically means that if the field is not present, if the client has not sent this field in the first place, then let's not validate that, because obviously the validation will fail there since it's absent. That's why for all those fields which are of pointer types, we also need to add this rule that leave this field from our validation pipeline if it is not present. Then comes our priority. We are using this rule called one of, you can refer to the documentation of Go Playground validator to understand what are the different types of rules that are available to us. But these are some of the common ones. The required, which means that this field has to be present. Then comes the one of, which basically an enum validation logic. You can provide a couple of values which are separated by space, and whatever the client sends in this field, it has to be one of these three values. It can be low, medium, or high. If it is anything other than that, then they'll get a bad request error. For due date, we are not adding any validation rule. For parent to do ID and category ID, we are saying omit empty, since this is a pointer type. And if it is present, then it should be a valid UUID. For metadata, again, we are not providing any validation rules. After we create our input struct, this is a struct that we are expecting for the create to do endpoint, the create to do API. For each struct, we have to add a method, a receiver method, so that our utility function, which I had explained in the boilerplate video, this utils function, any struct which has a method called validate, then it can take that struct and it can call the method validate on top of that. And whatever error is returned during that validation, it will be formatted using this function and will be returned to our client. Because of that, we have to declare a receiver method on this struct called validate. And inside that, we have to provide some validation executions. So we'll write something like this. For each struct in our input, we have to do this step, which is basically a receiver method. The name will always be validate. Inside this, we are creating a new validator instance, and we are validating this particular struct, whatever we are getting from P. And that takes care of our first DTO, the create to do API. Now that I have explained it thoroughly, I can speed up it a little and create all the other DTOs quickly. Now the second one is update to do. This will use for our patch endpoint. If we want to update a particular value of a to do, then we can use this endpoint and we can provide any of these values. As you can notice, all of these fields are of pointer types, which means that we are not expecting any of them. None of them are mandatory, and depending on presence of a field, we'll be conditionally updating it, and we'll see that when we implement the repository method. But from the DTO, we can see that all of them are optional fields except for this one field, which we are not expecting in our request body. As you can see, the tag here is not JSON. All the other fields have the tag JSON and validate, but the first field that we have declared here has the tag param. We are using Echo's native binding here. If you go inside the utils.go file, here in the first step, you can see that we are calling this method called bind, which comes from Echo. This particular method bind, what it looks for different tags. For example, if a data is coming in the request body, then it will try to take the information from the JSON tags. Similarly, if a data is coming inside a path parameter, then it will take param tags into account. Similarly, if a data is coming inside our query parameters, then we'll have to name the tag as query, right? So there are three major tags for making our binding logic work. One is JSON for loading our JSON data, our request body data, then param, whatever is coming from our path parameters, then we have query, which we will see in the get all to do's endpoint, get all to do's API. That is the reason for the first field we have written as param, because this is part of the URL. It is part of the path parameter. And the same way we have different validation rules. The first one is required and it should be a valid UUID. Then title and description, if they are present, then they should follow these rules. Minimum 1, maximum 255. For description, maximum is 1000. Status can be one of draft, active, completed, or archived. Priority, low, medium, high. Due date, there is no such rule. And for parent to do ID and category ID, they have to be a valid UUID. And again, for making our validation flow work, we have to declare a receiver method on top of it called validate. And inside that, we'll create a new validator instance and validate this particular struct that we get from here, P. Since this is a receiver method, let's divide it appropriately so that file does not look very cluttered. The next endpoint that I can think of is get all to do's. Right? We have created an API, at least the DTO, for create a to-do, then update a to-do, then we'll create an API for getting a list of all to-dos. Of course, every time we are thinking of creating a list endpoint, which basically returns an array of any kind of data structure, the first thing that we should take into account is whether we should implement pagination for that or not. And most of the cases we should apply pagination because it reduces the size of the response and we don't overwhelm the client with sending all the data that we have in our database. So pagination is mostly a good idea, and because of that we'll be using pagination for our get all to-dos API. And this is what the DTO is going to look like. As I said, this is a get endpoint. That's why we don't have a request body, and all of the tags follow this particular name called query, because this is a get endpoint and whatever data that we want to send will be coming from the query parameter. And because of that, all the tags have the name query. Again, none of them are mandatory. We can function even when client does not send us any query parameter. Even when they just call the API without any parameters, we can still function. That's why all of them are optional. All of them are pointer types. And we have different validation rules for each of the fields. Now here something interesting is happening inside our validate method. In the previous ones, what we used to do, we used to create a new validator instance and we used to return whatever the result of our validation back to the next middleware. Here what we are doing, we are creating a new validator instance and we are validating our struct. If there is an error, then we are returning from that point. If there are no errors, then we are setting some defaults. If after getting data from our client, if either of these 4 fields are not provided to us, then we are setting some default values before forwarding this whole data, this whole struct to our repository layer. And what are the fields that we are setting? We are setting the page. If page is not provided, then by default, we are setting the page number as 1. The limit we are setting as 20. The sort parameter, the default sort parameter, we are setting as created at, and the default order of the sort is descending, which basically means that if the client does not provide us any kind of pagination parameters, we are sending maximum 20 values and the first page of those 20 values, and all those values will be sorted in descending order as per the created at field, which means that we'll be sending the most recent to-dos on top. In that order, the oldest to-dos will be on the bottom, and that takes care of our get all to-dos API. And similarly, I'll go ahead and paste all the other DTOs. Next one is get to-do by ID. If we want to fetch a single to-do, then we have to pass that in our path parameter. And here there is no query, there is no request body or anything. We are just providing the ID of the to-do and we are returning the response. And this is how we are validating it again. Same for delete to-do. We are just providing the ID of the to-do and we are validating it, whether this particular ID is a valid UUID or not. Then we have another API endpoint, which is called get to-do stats, which basically sends some overall data, some statistics about how many to-dos that we have created, how many of them are in backlog, and how many of them are completed. So in a single view, because when we open our dashboard, we can get a high level idea that these are the numbers that we have for this week or for this month, etc. Right? That's what we are using for this particular API. And with that, all our DTOs for our to-do APIs are complete. Next up, let's go ahead and create all the DTOs that we need for our comment APIs. Right? So inside comment, let's create a new file called dto.go, and we'll need a couple of APIs here. First, to fetch all the comments of a particular to-do, then to update a particular comment, then to delete a comment, or to create a comment. So those are all the APIs that I can think of, which is pretty straightforward. So let me just paste it here. The package will be comment, and these will be the V10. So V10, and these will be all the DTOs. It is very straightforward. So I'll just go through them once. We can separate them out better here, and right. Okay, so quickly let's just go through them. First, we have the create comment payload. Again, to-do ID, we need the ID of the to-do, and this will be the path parameter that we'll be sending in. And we just need the content of the comment, which will be a text field, and the maximum number of characters can be 1,000 characters. Pretty straightforward. Then we are applying our validation here. Similarly, to get all the comments of a particular to-do, we are using this particular DTO, which will take the ID of the to-do in the path parameter. That's why we are providing param here. It should be a valid UUID, and it is a required, and then the validation. Same way for updating a comment, we need the ID of the comment, which we are taking in our path parameter using the param tag. Then the content of the updated comment. Then comes the validation. And lastly, for deleting a particular comment, we need the ID of the comment, which we are taking from the path parameter using the param tag. Then comes the validation. And that's pretty much all the APIs that we need for our comment APIs. And the last thing is category. So let's just go ahead and create a file called dto.go. Package will be category, and me add a divider here. The first one that we need is creating a new category. For that, of course, this will be a post endpoint, and in post we need to take data from a request body. So we'll need to keep everything inside JSON tags. And this is what it's going to look like. It's going to be v10. We are expecting 3 fields. 2 of them are mandatory. We need the name of the category and the color of the category, and the description is optional for the category. That's why we are using the pointer type here. And again, the validation rule for the name is minimum 1 character, maximum 100 characters. The color, it should be a required field, and the format should be a hexadecimal value of the color. Same way, description, if it is not provided, then we are leaving it out. If it is provided, then the maximum characters can be 255. Then we apply the validation here using a receiver method. Same way, let's apply the divider. We have the update category API. For updating a particular category, of course, we need to pass the ID of the category in the path parameter. So if you are not familiar with how we design our routes, then you can watch the routing video in the backend from first principles playlist. That should give you enough context about what we are talking about here: query parameters, path parameters, and request bodies, everything, how to design routes, what are the best practices, everything surrounding routing. Now coming back, we have our update endpoint here. We are passing the ID of the category in the path. Then we have 3 optional fields here: name, color, description. If the client can pass any of these fields and all of these fields depending on the use case, and we'll check the presence of each field, and depending on that we'll conditionally update those fields, and then we validate this as per these rules. We covered create category, update category. Then comes the get all categories. We need to send a list of all categories. Of course, again, since this is a list API, we need to think of pagination again. So this is going to be the structure. Let's add the divider here, right? Now we have a struct here, type get categories query, and these are all the query parameters that we are expecting. Now, one thing to keep in mind is I did not think of mentioning this best practice in the earlier DTO, but whenever you design get endpoints, especially get endpoints which return an array of something or a paginated data of something, always try to keep your query parameters as optional. None of these fields should be mandatory. You cannot make the client that it has to pass a page parameter or a limit parameter or a sort parameter. All of these have to be optional. If they are not present, then you can take your own same defaults, which we did in the last API. For page, we took by default the page as 1. For limit, we took as 20. For sort, we took as created at, and for the order, we took as descendant. Same logic applies for all different kinds of get endpoints. So for all the get APIs, always try to keep all the parameters as optional. We should not throw validation errors from a get endpoint. Of course, if they are passing something wrong, if they have passed limit and value of that limit is more than 100, then if we send a bad request error saying that it cannot exceed 100. That makes sense. But us sending a bad request error, a validation error, because of an absence of a field, that is a bad practice and you should avoid that. Now coming back, we have a similar structure here. We're expecting page, limit, sort, order, and search. So if the user wants to search some categories, they can pass that search query, whatever the user has typed in this field, and depending on that, we'll return our results. Okay. Now this part is pretty clear. We have been covering it in every single DTO. Then comes the validation. Again, first we perform the validation. If we get some errors, we check if error is not nil, then we return the error at this point. If there are no errors, then we set some defaults. As I said, if the client does not pass anything in these fields, then you can go ahead and set your own defaults. That's what we are doing here. If the client does not pass page, then we are setting it as 1. It does not pass limit, we are setting limit as 50. If it does not pass sort, by default, we are sorting by the name. And if it does not pass order, we are sorting by ascending order. And with that, all the DTOs are covered for to-dos and for our comments and for our categories. So from the next video, we can go ahead and we can work on our database queries and repository layer, our service layer, and our handler layer.